Alright, students, we're here with special angle relationships. Alright, so I got the guided notes on my right hand of the screen, iBook on the left hand side. You don't really need to get the iBook, but if you want to look at it, that's fine. You can just look at the iBook on my screen. And then in all seriousness, I would consider these notes the most important notes out of all the notes for the whole school year. Why? The stuff we're talking about today, complementary angles, supplementary angles, vertical angles, linear pair, they come up in just about every unit. All right, we use them all the time. Specifically, supplementary, vertical, and linear pairs. Not that complementary is not important, still important, but those three are probably the most important ones. All right, so let's just look at this interactive widget in the iBook. All right. So this is about complementary angles, so I can slide this back and forth as much as I want. I'm going to wait till someone tells me to stop. All right, I heard someone say stop right there. All right, now I'm going to do the slide me. So what do we think is so true about complementary angles? Well, complementary angles, appears that they add up to 90 degrees. All right, see how it doesn't matter what I do? The pink angle, the blue angle, they're always going to fill up a right angle. All right, so complementary angle means to fill up the right angle. All right, so definition, that's all we needed right there. Actually, hold on. Another thing is, notice these pink and blue angles up top. Notice how they're non-adjacent, they're not touching each other, but they can also touch each other. All right, so that's going to be a little bit of a fact in the future. But anyways, let's just go to the straight up notes now. Complementary angles are two angles whose measure add up to 90 degrees. Complementary, 90 degrees. It is important to realize that complementary angles do not have to be adjacent. All right, so here is an example one. I can just have some angle chilling over here. This is 30 degrees. And then this angle right here. Oops. We say that's 60 degrees. All right, these are non-adjacent complementary angles. All right, they don't share a side, or they can be adjacent. This is very famous one, is you just draw a right angle and you just have some interior ray coming out of it. These two angles should clearly be complementary. All right, so that's the punchline. That's literally it. All right, complementary angles. People say you can remember complementary angles because it's the right thing to do. Get it? Compliments. It's a right thing to give compliments at right angle. Haha. Anyways, enough with the jokes. We're going to do two problems with complementary angles. So angle A and angle B are complementary. So the skill we have to develop is right when we see the word complementary, 90 degrees. All right, and then this really just turns into an angle addition problem. We got measure of angle A equals 3x minus 9, and the measure of angle B equals 2x plus 14. Find the measures of angle A and angle B. So all I got to do is say, well, since they're complementary, 3x minus 9 plus 2x plus 14 equals 90 degrees. Setting up this purple equation's the hardest part. Then it's a matter of just solving it. Boom, boom, 5x. Boom, boom, plus 5 equals 90 degrees. All right. Then I'm going to subtract 5 from both sides. I'm going to get 5x equals 85. And then I'm going to divide both sides by 5. And x equals 17. All right. Next part. Remember, we got to read the question. This is a skill to develop. Read the question, answer it. It says find the measure of angle A and the measure of angle B. So all I'm going to do is take 5 and plug it in for x. All right, so I'm gonna have 3 times 5 minus 9. Oh, timeout, not 5. Brain fart, 17. So embarrassed that I said that. X is 17. I'm gonna plug in 17 for X. I'm gonna 3 times 17, 51 minus 9 equals 42 degrees. All right, I'll make this a little smaller so I can cram this all in, or I'm gonna move that up there. All right, now I'm really nervous. Why? Because the angles are complementary, so I know I can do it in my head really fast. Measure of angle B has to be 48 degrees. Technically, I don't have to plug it in. I just say, well, 42 plus 48 is 90 degrees. They're supposed to be complementary. So technically, I don't have to plug it in, but I'm going to plug in X, and whew, I ended up getting 48 degrees. Yes. All right, so nice. Typical complementary problem. Complementary, 90 degrees. Adding the angles up to equal 90 degrees. Solving for X, plugging it back in. All right. Now here's a ratio problem. Angle JKL is 4 times as large as LKM. All right. So it's 4 times as large, so I can say 4 to 1. All right. JKL is 4 times larger than LKM. However, that's not their exact measures. It's not a measure of 4. It's not a measure of 1. That's just the ratio. We don't know the exact measure. In math, when we don't know something, we like to call it X. So rather than call JKL 4 and LKM 1, I'm going to call it 4X and 1X. All right? Or, which is just X. A little bit of redundancy to write 1X. Anywho, there's a bunch of ways to solve this problem. This is the way I like to do it. Again, you can do whatever you want, just as long as you get the right answer and it doesn't incorporate cheating. All right, so they're complementary. How do I know that? They're two angles, 90 degrees right there. So I'm going to set up 4x plus x equals 90 degrees. 5x equals 90 degrees. Divide both sides by 5. X equals 18. Then it's telling me to find the measures of the angles. So really, plug in x for x. That measures 18 degrees. This should be 72, but let me actually do 4 times 18 to confirm. It is. Woo! Yay! All right, so that's complementary angles. You got a follow-up problem in Canvas, and we'll talk about supplementary angles next. Stay tuned.